All right, this is AP Calculus Worksheet 8-3. This is the key. Hopefully I will make not too many mistakes, but a little bit so that you get some extra credit. All mistakes are made on purpose. I just want everyone knowing that. All right. Number one. Starting now, yes. Actually, that's always been the case. I just had to point it out now. I'm probably going to need this equation. I do that on purpose. I need to give you guys some bonus points. Just make sure you're awake. 5-second squared root of, that's going to be t, in parentheses, cosine of that divided by 5. Cool, I have my equation. Let's get rid of this. There are 1,000 mosquitoes at time equals 0, so that is my start information. I need both the start time and the start amount. According to the model, how many mosquitoes will be on the island at t is equal to 31? So that means if I'm doing my table, I'm saying my t. Here's my informal table. You don't need to make a full table. I'm just showing you my work here. This is my start plus change is equal to the end. So my t here is t is equal to 31. My start is 1,000. My change is the integral from my start time 0 to the time it's asking for, 31. And it's then to be that capital R of t dt equation. So I just type this into my calculator. I say, yes, take 1,000, and I'm going to add math 9, the integral of y1, var's right, enter, y1 with respect to x from 0 to 31, and I get an answer. One time, it took all day. Now, come on, let's go, computer. I feel like there should be a way to like speed this up since it's an emulator, like times 1,000 speed. I know you can do that with like Game Boy emulators and stuff. Oh my gosh, is yours still computing too, kids? My beautiful students? There it goes. 964! 964.335. And then it says round your answer to the nearest whole number. So our final answer here in red is going to be 964. Mosquitoes, it doesn't say units, but we'll always do units so we don't get the point ever taken off. Mosquitoes. All right, we're talking about a storm now. Aaron's gonna have a fun time retyping this one. A storm is washing sand away, so we're removing sand. There's our function. We're probably gonna need that in here. In fact, I don't need to keep entering it in y1. I'll show you a quicker way now. So there, it's gone. The storm lasted 5 hours. The edge of the water was 35 when it began. So this is my start information. 35 meters away. What was the distance at the end of the storm? So I'm going to do the start condition. I'm not going to do my table anymore. I'm just hoping that we can memorize that we're doing start plus change is equal to end. So I'm now doing 35, my start, plus my change, my integral from my start time, which is 0, because it's t after the storm began. I didn't begin at 0, and then began after that, right? From 0 to 5 of that lowercase f of t dt function. All right, so on our calculators, the way that I do that is I just say my start condition of 35, I'll leave this over here, 35 plus, and then it's going to be math 9 again, and you can actually type in the function here. So the function is going to be second square root of x and the square root plus cosine of x, and the parentheses minus 3, then comma, letting you know that you're done with your function. Really briefly, the reason that you sometimes want to enter it into the y equal function is you don't have to end your parentheses, so you can speed up time that way. You 100% always have to end your parentheses whenever you're entering it into this format, and you did in this case because you had to do subtract 3 anyway. And this is with respect to x from 0 to 5, and hit enter. You don't have to end the parentheses for the final function for the integral, bless you. And we get an answer, which again is going to take its sweet time. 26.495. 26.4 495. Our units here are meters because it was meters per hour, and then we took the integral, so it gets rid of our time, so just meters. And it doesn't say that we have to round. We're good. We're on to number 3. Water is pumped into an underground tank, so we have a positive rate at 8 gallons per minute. I'm going to put a plus to let me know that's a positive rate, and it leaks at this rate. Hey, we've seen this problem before. And then we have some start information. Our start time is 0. Our start amount is 30. It's asking for how much. So if you ever see how much after a certain amount of time, you're doing start plus change is equal to n. So 30 is our start. Our change is between our start time of 0 to this time 3 of that. Ooh, so it's going to be the positive minus the negative, right?
Yeah.
So I'm going to do the positive 8 minus the negative, the square root of t plus 1, all of that thing dt. All right, so I have to type this all in my calculator. Again, I'm going to kind of do the same thing that I did before. So I'm going to do my start condition of 30, right? 30 plus math 9, and then type in this function. 8 minus the square root of t minus 1, which is x minus 1, and the parentheses for the square root, and then comma with respect to x from 0 to 3. Uh-oh. What'd I do? I ended my parentheses for the square root. Was it not liking? 8 minus the square root of x minus 1.
Oh, you need a second then, parentheses, don't you?
That's entering the
integral of that.
This parenthesis should be ended technically over here. You don't ever have to type that last parenthesis if you don't want to. Non-real answer.
Can't see it.
Oh, non-real answer means we have a square root of a negative?
Yeah, so then how did t become negative? Did you accidentally put -3?
No, it says from 0 to 3. That's interesting. I wonder if it happens if I come back here and enter it in here. So if I do 8 minus the square root of x plus 1, I'll end my parentheses to be very careful now and quit out of this. Sure, I'm going to now change this to 30 plus math 9 of...
t plus 1, not t minus 1.
Oh, is that what I made this make?
Yeah.
Ah, darn it. Okay. Yeah, cool. Log it. y1 with respect to x from 0 to 3. That totally makes sense now. I should have looked for that. 49.3 repeating is equal to 49.333, round to 3 decimal places, and that is gallons.
Did you do 3 repeating?
You can't do 3 repeating. You always have to round to 3 decimal places for AP. I know that you just want to say 3 bar like that, but you just round to 3 decimal places.
What's that thing called? Mr. Brown quizzed us on it yesterday.
Oh, yeah.
It has a name?
Apparently.
Cool. I just called 3 repeating.
It starts with a V.
Alright, slight tangent. Sorry, people watching this video in the future. What is the name of the bar for repeating decimals? That is called a vernaculum. Oh, really? I actually kind of remember that word. Does that have other meanings as well?
Yeah, it sounds familiar.
It's used in mathematical notation.
Okay, cool. Vernaculum. Now you know. Let's see if I can remember it too. Quiz me tomorrow. All right, part B. Write an expression for the total number of gallons at time t. So that's going to be the same thing, but that 3 is going to be changed to a t.
So isn't this a problem because of the T?
Yeah. That's interesting. Maybe I'm being overly cautious. This is taken from an AP exam. I can tell by the type of question. I've seen this before on an AP exam, so I guess it doesn't matter.
Okay.
From 0 to t of 8 minus the square root of t minus 1, all of that in parentheses, dt. Done. Number 4. At a certain height, a tree trunk has a circular cross-section. Here's the rate of that cross-section. T is measured in years. We have some start information right here. Our start time is 0. Our start radius is 6. Write an expression for the radius. So now we're doing this expression, kind of the general expression, and then using it to find what happens when time is equal to 3. So I'm going to do the start. Plus change is equal to n. So 6 plus the change. The change is going to be between 0 and t. of our integral. So I'm just going to say, I think it's okay if we just say d capital R over dt. I guess dt. Does this cancel out? Do I have to worry about that? I think that's fine. And yeah, let's call that good. Let's go ahead and use our expression to find our integral. This is a calculator question because I have a t squared in there, right? Could I do this without a calculator? I wonder.
That doesn't mean we should do it without it.
Yeah, I mean, it's always easier with a calculator.
You could 100% do this. No, you couldn't. Okay, because it's t squared. So if you use taxman, you'll be paying taxman with a variable rate. You're going to need a calculator on this one. So I don't even need to write anything down aside from r of 3 is equal to this thing where that's a 3. So I'm not going to write anything down. I'm going to come back to my calculator and say 6 plus math 9, the integral from 0, no, sorry, integral of the function, I have to type all this in, 1 divided by 16. And I do have to write times, I think. Yeah, because otherwise that's going to be all weird. Times, and I'm going to do parentheses just to be sure I'm doing this right. 3 plus sine of x squared. That squared is on the inside applying to the t. And this is closing the parentheses for the beginning of the 3 here. That is our entire function. Comma with respect to x, comma from 0, comma to 3. And if I did that all correctly, I should get 6.611. 6.611. Our units are in centimeters, so cm. All right. We are on to number 5. And we're out of here in a minute and a half. So this is going to be, W is pumped into the tank, so that's going to be our positive rate. Our negative rate is going to be water removed. So estimate, or to the nearest whole number, how many gallons are at time is equal to 18. So I start with 1,200. I forgot to label my start information. Always label your start information, especially on the tests and stuff. On the homework, if you're being lazy, don't. Just label it. Get in the habit of doing it. So I'm going to do 1,200 plus the change. So start plus change. The change from 0, because time is 0 from the start, to time is equal to 18. 18 of the positive rate. So I'm going to say capital W of t minus the negative rate minus a capital R of t. All of that thing dt. And here we go. 1,200. Okay, this is going to be a little bit hairy. Am I worried about? No, this is kind of all simple. If this had lots of pluses and minuses, I probably would enter it into y1 and y2 to make sure I get everything right, but this is going to be fine. So plus math 9 of, here we go. So it's going to be 95 square root, we have 10 seconds left. Well, I'll finish this in a sec. All right, so coming back, yes, I'm entering in the t and the parentheses. That's going to be sine of t divided by 6, and then after that, square it. Okay, so that's the first function. And then I'm going to subtract the second function. That's going to be 275, and then it's going to be sine of the same thing, x divided by 3, that quantity squared. Okay, those are all of our functions. Now I do my comma with respect to x from 0 to 18. That was a lot of entering equations. Hopefully we didn't make any mistakes. We'll see. And it's doing its thing. This might take a while. It's a bunch of trig functions. Curves always take longer. There it is, 1,309.788. 1,309.788. Our units here are gallons. And I did write that correctly. All right, so part B. After time is equal to 18, no water is pumped into a tank, and it's just going to be continuously removed at r of t. Okay. Right, but do not solve an equation involving the integral expression that can be used to find a value of k. For k be a time at which it becomes empty. So, we have to figure out when it becomes empty. We have to set it up, but don't solve. All right, well, essentially what I have is I now know that I am starting with this amount because that's how much is at time is equal to 18. We just solved that in part A. So I'm going to write down, you can, like, I guess if you're doing this for the AP test and you didn't know how to actually calculate this thing, like you typed in your answer wrong, to be very careful, you could say, okay, well, that's my initial amount. You could write out the integral, but I'm being lazy. I'm just going to say 1,309.788. And then I'm going to subtract r of t, right? So subtract the integral between 0 and I don't know what time it's going to be empty. So k is the time that it's empty, of r of t, because r of t is the negative rate, dt. And so this is start amount and then subtract some amount, and I want that to become empty. So make that set equal to 0 and done, solved it. Moving on to number 6. There are 700 people on the line for the popular amusement ride park. Closes 8 hours later. 800 people per hour, that's a consistent rate. It's measured in people per hour. Right, but you do not solve an equation whose solution gives the earliest time at which there will no longer be a line. So when is the line gone? When are these 800, or sorry, when is the original 700, I should write the start here. That's our start information. When are those 700 people gone? Well, it's always going to be start plus change, so 700, and then I'm going to, they are moving onto a ride at a rate of 800 people per hour. Is there any positive rate here? Maybe I should read the entire problem. Yeah, so it looks like it's just minus the 800, so it's going to be minus the integral between 0 and what is the time that we're looking for, r, or earliest time t, so from 0 to time t. I'm just going to say 0 to t, and this is going to be r. This whole thing is going to be r. I'll talk about that in a sec. And this is going to be the integration of just 800. Or I could have done plus and then negative 800 right there. It doesn't really matter. Just know that this is a negative rate, so I have to either subtract it one way or another. dt, and I need to see when that thing is set equal to 0. So write an integral expression r, who gives the earliest time. So how could I make this when there's no longer a ride? I don't understand what it means by r, and I'm totally blanking on what this means. I don't want to say anything along the lines of like this is set equal to r or something, because that will change depending on what time t there's no longer a ride. So the earliest time t, I'm just going to say that's set equal to 0. As long as you know that this is the general way of finding the time t at which there is no line for a ride, then you're good. Let's move to number 7. Number 7. All right, we have a piecewise function, probably the snow one. Yeah, so snow one. So this is the positive rate here because it's accumulating. So I'll underline accumulate, and then removes snow. So this is going to be the negative rate. And I need to know how much is on the driveway at 9. And notice that I'm going to have to do the piecewise function 1, 2, 3 times to get all the way to that 9 o'clock. So how am I going to do this? Well, I'm probably going to do the positive rate. I'm going to deal purely with, I could do 3 separate integrals and make them all kind of jumbled, but I'm going to do just the positive rate minus the negative rate and figure out what that is. So the positive rate, that one is going to be the integral between 0 and 9 of f of t, lowercase f of t, dt. I'll find that on my calculator in a sec. And then I'm going to subtract this. There are 3 different pieces, so there should be 3 different integrals. So minus, and then I'm going to set up some brackets here. Minus, well, I don't have to do anything here. I would like to say, okay, integral from 0 to 6 of 0. That doesn't make sense. Nothing is happening. No snow is being removed. I'm going to ignore it. I only really need these 2 pieces. So I'm going to do the integral between 6 and 0, or 6 and 7, Mr. Snell, 6 and 7 of 125. And the fact that it's a negative rate is coming from the fact that I put a negative there already. That's going to be dt, and then plus the other amount. So this is going to be integral from 7 to 9 of 108 dt. All right, so that's setting it all up. Now I actually have to do the calculation. So this is going to be done with the calculator. So let's clear out of all of this. And do I have any initial amount that's happening? No, it doesn't say any initial amount. There's no start condition in this one. Very rare does that actually happen. Always check for your start condition. Math 9, integral of f of t. It's going to be 7x second natural log to get to the e to the power of cosine of x, n parenthesis. So I've ended the parenthesis for the e, ended the parenthesis for the cosine, comma, not the parenthesis for the integration yet, with respect to x from 0 to 9. And that will solve this integral right here. Go calculator, go. And it probably is a nice idea to store that variable. It is a valuable variable. 367.334. 367.774. 334. What am I saying? 334. 334. There we go. I'm just going to leave that for now. This one I can calculate by hand. You don't have to type it in because the shortcut is do upper bound minus lower bound. Upper bound minus lower bound times 125 times whatever constant amount you have plus 9 minus 7, that's a bad 7, that's a better 7, times your 108. 7 minus 6 is 1, so this is going to be 125. I'll write it up above, 125. And 9 minus 7 is 2. 2 times 108 is 216. Adding these together, that's going to be really subtracting 341. Don't know why my 4 is so far over. 341. So I really need to do that thing. Wait. Yeah, okay. I was like, wait, is this a bigger number? Otherwise, I have negative snow amount, which doesn't make sense. Yeah, this doesn't make sense. So I'm going to say, yeah, just minus 341. I don't even know why I did that. It's just 26 because it's a nice, easy subtraction. So my final answer here is 26.334. Just rewriting this line again. This is 367.334. There was a minus sign up here somewhere. And we can box our final answer. Oh, we need units. What are our units in cubic feet? So I'm going to say feet cubed. And that concludes worksheet 8-3.